So we have placed an obstruction in front of the car. Now when we start our program, it is scanning the object and it found the object in the path. Car started moving. It took a right turn to avoid the object. Now it's aligning. Try to it's back into the track. Now we have placed a stop sign and the car is stopping for 5 seconds before moving. So it's moved and again second scan, it's stopped for 5 seconds. Now we have removed that stop sign. So it is going straight now as per path. It was decided by the A-star algorithm. So the car is stopped there, and here is the path, final path. If you can see the car avoided the obstruction scanned by.
Let's go through the object detection code. As you can see, this is the function which is being called for object detection. The first parameter is name of the model. It's the TensorFlow Lite version. The second option is the number of items for camera to detect simultaneously, so it's 2. The third value is the threshold for accuracy. Right now it's 0.4, which is like 40%. The third option is the slot of pi camera. Of course, we only have one pi camera, so it's 0. And the fourth and fifth are the number of pixels for the picture. As you can see, we are using MediaPipe library here, PyCamera, utils for visual and CV2, and of course plus time and system. Here we are importing the PyCamera. We are configuring to be 640 by 480 pixels. Of course, it's in RGB, and we are providing a preview for it as well. This is one of our functions. This function, as you can see, it will extract the name of the category name for the object it detects. In case the object name is stop sign or traffic light, it will return a value of 0 or 1. For anything else, it will return 3. And this is a call for our run function. Here we're specifying the text on the purview model, like okay, we have detection result list where all the information will be stored. Here we are setting up the number of frames to be calculated. This is calling the base option model for object detection, so we are setting it up here. Okay, this function calls the PyCamera continuously, so we are scanning continuously. As a new object is detected, it will be automatically saved to this detection result list. And Yes, right now we just for the sake of preview, I'm printing this value, but then the actual code that we are running, along with the ultrasonic scanning and everything else, so the value is directly returned there. Nothing is printed. If it's like 1 or 0, we will stop, or if it's 3, we will continue moving. And one important thing, I'm adding, like, of course, the frame rate. I want to reduce the frame rate, so I'm adding a 1 second delay after like each loop. So we have 1 frame rate, 1 second frame rate capture. I will run the code for you. So this is the code. As you can see, it detects, let me display something. Read this, can be detected. Okay, it's detecting a cell phone, but anyways, you got an idea. If it's like a stop sign, then of course it will show a stop sign. That's it. Thank you very much.
I will give a full walkthrough of the PyCar self-drive, which is our main function. Here we are importing the image recognition module, which will be used to detect any stop sign. The first step is scanning. We will do a ultrasonic scan of a range of 180 degrees, starting from -90 to 90, and print those results here. Next is the advanced mapping, which we will calculate through Manhattan distance and A-star algorithm. It will calculate a F-score for each node and select the one with the lowest F-score. So that is to calculate the shortest distance between the two paths. Also, it will consider, for each node, it will consider the neighbors and get the G-score for them. Once we get the path, we will try to calculate the how to reach there through the directions like right, left, up and down. So this function will perform that, and then once the path is calculated, it will convert it into PyCar movements, like the control functions of the PyCar, which will actually drive the car. And this function will be used in our main function. As we can see that we have set a start goal in the main function, starting from 50:00 to 50:30. We put some obstacle in between, and you can see that in the actual car driving demo video. Then it if the path is present, it will get the moves and perform the move in loop. While doing the moves to reach the destination, it will keep scanning and see if it can see any stop sign. So the image recognition module is designed in such a way that if it receives a stop sign, it will return 0. If it is a traffic light, it will detect 1, something like that. So we have considered just the stop sign here, and if it gets a stop sign, it will sleep for 5 minutes, like stop for 5 minutes, and then it will start again. So you can see that in the demo video, and at the end it will once this performed functions are done, it will print the path that it took. That's it. Thank you.